Welcome to the third part of the linear equations revision. Students, you can access these questions on the sheet that was handed out. Now, transform the following to change the subject. Now, this is equation, I'll just rewrite it, P is equal to V times by I. This is an equation which is talking about the power that may be in an electrical circuit is equal to the voltage times by the current passing through that circuit, and we're wanting to rearrange this, find I to make I equal to something. So we want to leave I on its own, and we look at what's joined onto the I. It's a V joined by a times sign, so in order to get rid of that we have to divide both sides by V. So we have V divided by V, they will cancel down. That will leave us with I all on its little old lonesome on the right hand side, and that'll be equal to P over V on the left hand side. So that's actually what our equation end result is. I is equal to P over V. Next question that we've got here, V is equal to U plus AT. This again is a question out of physics which is dealing with motion, and we're wanting to rearrange this to find A. So this is written as V equals U plus AT, or A times T. So we want to keep the A on its own, the T is joined on by a times sign and the U by a plus. If we do our reverse order of operations, what we need to do is to go take away firstly U from both sides. So we want to take away U from each of the sides. So I'll just rewrite that out. So we're going to have V take away U will be equal to U plus AT take away U, and that U will cancel each other down. So that will leave us with V take away U is equal to AT. The next thing we need to do to get A on its own is to move the T. So it's A times T. The opposite of times is divide, so we're going to divide both sides by T. That's then going to cancel that down. That will now leave us with A is equal to V minus U over T. That's the answer there. Let's move on to the next example. This one here is an equation that represents a circular graph. We want to rearrange this to find x. So we want to make it as x is equal to something. So what we need to do is firstly get x's on their own, so we can see that there is y squared on the same side of the equals as x squared on the left hand side there. So what we'll need to do is take away y squared from both sides. And that's actually going to cancel that down and leave us with x squared is equal to 9 take away y squared. Now the next thing that we have to do is deal with this square. So the opposite of squaring something is to take the square root. So what we need to do is to take the square root of both sides, and that effectively cancels that down, leaves us with x on its own on the left hand side. That'll be equal to the square root of everything on the right hand side, which is 9 minus y squared. And that is the answer to that one. Let's move on to the next equation. And the last example we have here, we're needing to find U. So there's a few things on the right hand side along with the U that we're going to need to move. This is U times T, and then they've also got this plus AT squared. So honestly, the easiest way of dealing with this whole plus AT squared stuff is to take away a half AT squared from both sides. And that is going to cancel that down. So what we'll be left with is x minus a half AT squared is equal to UT. Now the next thing that we have to do is to to get u on its own is to divide everything by t, because this is u times t on the right hand side. So we're going to divide that by t, but we also need to divide everything on the right hand side by t, each of the individual terms, like that. And that will cancel that down, and that will now leave us with u on the right hand side here, and we'll just swap that around in a minute. Now, the t on the bottom of this second term will cancel down with one of these t's on the top, so it's no longer a t squared. So what we'll end up with on the left hand side is x over t, take away a half a t, and that is a result that you can have for that one there. It does look a little bit messy, and there are some other ways in which we can arrange this, but we'll just leave it like that for now. Okay, I hope you find that a bit useful. Bye.